Today we're going to begin Unit 8, which deals with right angle or right triangles and similarity. Our first lesson will be on the Pythagorean theorem and its converse. We've talked about the Pythagorean theorem a little bit already, as we've talked about how to find distance between 2 points. So we'll elaborate on the Pythagorean theorem a little bit more and get more into the converse of the Pythagorean theorem. So some basics as we begin. The legs. The Pythagorean theorem works for a right triangle, and the legs are the two sides that form the right angle, and we call those A and B. Then the hypotenuse is the side opposite the right angle, so it's also the longest side of the triangle, and we call that C. Okay, so the Pythagorean theorem in words states that if a triangle is a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. And we use a squared plus b squared equals c squared as the algebra for that. So let's take a look at a problem that we can apply the Pythagorean theorem for. So in this case we have a right triangle. These are already labeled A, B, and C. A I don't know. B is 6, and C is 7. So the important part is always to find what are the legs and which one's the hypotenuse. I could call this one B and this one A if I wanted to, but the hypotenuse is always C. So A squared plus 36 is equal to 49. Solving for A, I subtract 36 from both sides, and that'll leave me with A squared equal to 13. And to undo the square, we take the square root. So A is the square root of 13. We could leave that. That's as simplified as we can get the square root of 13. You can approximate it if you'd like. In the example below, we've got 5, 12, and C. We're assuming this is a right angle. So we don't know the hypotenuse, so we'll leave that one, but we square the 5 and the 12. And the sum of those is equal to our hypotenuse squared. 5 squared is 25, 12 squared is 144. And that equals C squared. I combine 25 and 144 to get 169. Is C squared. Take the square root of 169 is equal to C. 169 is a perfect square, so C will be exactly 13. So if we can take the square root exactly, we can do that. Otherwise, feel free to leave it as in its radical form. Now, let's take a look at this one. We have x plus 2 and x as the legs, and square root of 10 as the hypotenuse. So in order to solve for x, we plug in x plus 2 and x for the two legs, a and b. And our hypotenuse is square root of 10. Square root of 10 squared. Next we simplify. Now here's where we got to remember some algebra. So when we take x plus 2 squared, remember that's really x plus 2 times x plus 2. X plus 2 two times. So we've got to distribute that out. So x times x is x squared. X times 2 is 2x. And 2 times x is another 2x, that's plus 4x. And then 2 times 2 is 4. And then plus another x squared. And square root of 10 squared is 10. Now I combine like terms. X squared and x squared is 2x squared plus 4x plus 4 equals 10. And then we get, now we can't get the x on one side because we've got a squared term and a regular x. So in order to solve these, we've got it, this is a quadratic equation. Let's get it equal to 0. Remember, there are different methods for solving that. So if we get it equal to 0, we can look to either factor, complete the square, or use quadratic formula to solve to find what x is. At this point, I see all the terms can be divisible by 2, so if I divide both sides of the equation by 2, That'll leave me with, I'll move my work up here now, x squared plus 2x minus 3 equals 0. At this point I remember how to factor. I'm trying to find two numbers that multiply to give me -3 but combine to give me 2. So I know x squared is going to be x times x. And how do I multiply to get -3? Well, 3 and 1. 3 has to be positive. The 1 has to be negative, so they combine to give me 2. Because x squared plus 3x and minus 1x gives me 2x, and then 3 times -1 is -3. So hopefully you remember how to factor from algebra. Then we use the zero product property. So this term equals 0, or x minus 1 equals 0. Then we solve both of those. Subtract 3, x equals -3, or add 1, x equals 1. So in this case, we need to determine which value it's going to be. Well, -3 plus 2 is going to be a negative number, so we can't have a negative distance. So in this case, x will be 1, because 1 plus 2 is 3, and this will give us 1. So 3 squared plus 1 squared will give us square root of 10 squared. Okay? So eliminate the answers that don't make sense. Why don't you try numbers 2 and 3 on your own and check your answer when you're ready. So problem 2, we had the right triangle that's leg 3 inches longer than the other leg. So one of them is x, the other is x plus 3, and the hypotenuse is 15. To find the unknown lengths, these are the two legs, so x plus 3 squared plus x squared equals 15 squared. I multiply x plus 3 squared to get x squared plus 6x plus 9 plus the x squared equals 225. Combine my terms to get 2x squared plus 6x plus 9. Subtract 225 from both sides to get 2x squared plus 6x minus 216. Then I can divide both sides of the equation by 2. That gives me x squared plus 3x minus 108. Then I factor that down. Factors of -108 that combine to give me a sum of 3 are 12 and -9. So x plus 12 times x minus 9 equals 0. Therefore, x has to be -12 or 9. Since we can't have a negative length, our solution has to be 9. So this side is 9, this one is 12 inches. Example 3, we have the swimming pool 30 feet wide by 60 feet long. We would swim diagonally across. How far did we swim to the nearest foot? 30 and 60 make up the two legs, so 30 squared plus 60 squared is c squared. 900 plus 3600. So c squared is 4500. Take the square root of that, and it's approximately 67 feet. Now I'd like you to finish up by exploring the converse of the Pythagorean theorem. The converse states that if a squared plus b squared equals c squared, then it is a right triangle. So the converse would be if a squared plus b squared does not equal c squared, then it is not a right triangle. So we're going to explore that. The way we're going to do that, you have 9 triangles here. I'd like you to estimate the type of triangle that it is, and you'll put that in the blank on the table here. So we don't necessarily need to have the sides. Let's just name it by angle. So is it acute, right, or obtuse? So this one, I can see that I have a right angle here. So triangle 1 is a right triangle, and its side lengths are 3, 4, and the hypotenuse would be 5. So I'm going to go down, and in my table, I'm going to write that it is a right triangle. And we use the two shortest sides. So I'm going to take side squared plus side squared. The two shortest sides, so we have 3, 4, and 5. So side 1 will be 3 squared, and the other one is 4 squared. And then the longest side was 5, so 5 squared. And then I'll simplify those. 5 squared is 25. And 3 squared is 9. 4 squared is 16. 9 plus 16 is also 25. So I'll calculate the values of those, and I'll put the inequality or equality equal sign in there. So greater than, less than, or equal. So 25 is equal to 25. Okay. Then you'll go through that for the next 8 triangles. And then when you're done, you see if you can make a conjecture based off that to confirm the converse. It'll ask you to highlight all triangles that are acute, all triangles that are obtuse with a different color, and all right triangles with a different color, and check the corresponding data in the table. And then it asks you to assume that you're given only a side length of a triangle. Can you determine if it's right, acute, or obtuse? So see if you can find a pattern with that and be ready to explain that in writing there. And then when you get to class, you can check in with me and I'll let you know if you figured it out or not. So that is how I would like you to finish up before you begin working on the assignment.